In section 2.8, we're going to connect this idea we had from conditional statements before to the idea we had in the previous section on quantifiers. So let's see what we mean by that. So let's look at the statement we have here. It says x is a multiple of 6, implies x is even. So if we think about this, right, we've seen statements of this form before. We're just trying to get down the logic of it. We know that for every x that's a multiple of 6, right? So if x is equals 6 times some n, where n is in z, that's what it by definition means to be a multiple of 6, then we know that x is equal to 3 times 2n, or maybe I should write this as 2 times 3n. So it's 2 times an integer. Therefore, it's even. So I know for any time this is true, this is also true. So we can't get that bad true, false. So this overall statement is true for every x. And in fact, that's what we mean when we write this sort of statement. So what do we usually mean? What we really mean here is for all x, x is a multiple of 6 implies x is even. So when we have these implications or these conditional statements that have variables in them, x, so we end up with some sort of open statement, what we really mean is to have that for all x. So then this actually becomes a statement instead of that open sentence. So let's go ahead and summarize that a little bit on the next slide. So the main idea here is if we ever have two open sentences, so any p of x and q of x, where x comes from some domain set S, and we're given this statement, the conditional statement p of x implies q of x, really what that means is for all x and s, p of x implies q of x. So we're not going to say, oh, well, this is really an open sentence, which is true for some x and false for others. We're going to really think of this as some sort of statement. And either the implication is true for all x and s, or at least one of them it's not true, in which it's true all the time. So this p of x implies q of x is true if it's true for all x and s, and it's false if it's false for at least one x and s, or there exists some x and s such that p of x implies q of x is false. So it's good to keep in mind that when we have a conditional statement here, or a conditional using open sentences, then we really have this implied for all x and s. To practice with this idea, I've given several conditionals here. Remember that for each of these, we should think of them as having a for all x in R, or for all p in R, maybe, or in z greater than or equal to 2, since I'm worrying about it being prime. Here we're talking about functions that are differentiable on R, so I could say for all f from the set of functions. So think about those statements that way, and then I want you to determine if they're true or if they're false, and see if you can give a little explanation about why.